Okay, so what is a resistor? A resistor is a tiny component that we've seen in many projects that is used to protect other components from overheating. Um, they are conductors of electricity and they let a certain amount of current through. Okay, that's why there's lots and lots of different types of them. So we get the right amount of current that we need flowing through the circuit in order to make the circuit work. So we've all seen this circuit before, resistor and LED, especially in our first year projects. And we know that the current rating for an LED is 20 milliamps. Okay, so if we want the LED to light up, we need 20 milliamps flowing through here. So this random resistor here, 15K, so 15,000 ohms, is letting through 483.14 microamps. Okay, it's a very, very small amount of current, not enough to make this LED light up. If we change its value to say 350 ohms, there's a unit for ohms, and run it, we can just about see our LED is lighting up there. All right, there's a green glow around it. It's working nicely, and there is a current rating of or voltage of a current rating of 19.4 milliamps. Okay, which is the current rating for an LED, 20 milliamps. Okay, so we're nearly there. So that's about spot on. Okay, now. So current flows around through the circuit to make the LED light up. Now, what is current? So in a copper wire, we have copper atoms, and the atom is surrounded by an electron, and the electrons move around. Okay, the electrons can move from atom to atom. So in a circuit like this, where we have a battery and some copper wire, the electrons are flowing around, and when they get to the component in the circuit, like this bulb here, the bulb lights up. Or if it was a speaker, the speaker would make noise, or it would generate heat if it was an element. Okay, so the battery is here to push the current around. The voltage is pushing the electrons around the wire to create electricity to make our component work. Okay, now so we have to get the right current around the circuit to make the LED work, and all the resistors have different values, you know. So let's just test the simulator here. See, this resistor has 470 ohms. Okay, and let's jump over here. This resistor, different colors, has a value of 330 ohms. Okay, so how do we know what resistor to choose? Okay, so if we go to where is it? Oh, yeah. So if we go to our resistor here, all right, this is our example here, and here's our resistor color code. Okay, and we can be asked in the exam, how do we know what value resistor this is? Okay, they'll give you a resistor and tell you what is its value. Okay, so we look at the first three colors here, the first three bands. Okay, and we also have to look at the identifier over here. So this is going to tell us whether it's a 5%, right, or a 10% resistor. All right, this is the tolerance level here. All right, and we always keep this tolerance level band, all right, whether it's gold or silver, on the right hand side. So we work out our resistor value from the left hand side. We start over here on the left, the opposite side to our tolerance band. So yellow here is our first color, and yellow is 4. So we write that down on our sheet of paper or whatever. And our second color here is violet or purple, and that is 7. Now our third band is the most important. That's our multiplier. And whatever color that is, we write down the number of zeros that color represents. All right, so this one here is orange, and orange is 3. So we write down 3 zeros. So the value of this resistor is 47,000 ohms, and we always put in our unit there, okay, our symbol. Or we could write down 47 kilo, small k, ohms, which looks a little bit neater and a little bit tidier. So that value of resistor there is 47 kilo ohms.